Here is a sentence. Mitigating the risk of extinction from AI should be a global priority alongside other societal scale risks, such as pandemics and nuclear war. That is the whole thing. One sentence. It appeared in May of 2023, and the strange part was not the language. It was the names underneath. Researchers who built the field of artificial intelligence, including a man who would win a Nobel Prize the next year for work that helped make these machines possible. And beside them, the leaders of the companies racing to build what the sentence is about. The people closest to the machinery signed a public warning that AI could become an extinction risk. Then the meeting ended. The labs reopened. The race kept moving. A signature is not proof. It is only a signal that the people with the clearest view into the engine did not think this belonged in the same drawer as flying cars and tabloid prophecy. Two of the people behind that warning thought it was much too mild. They had spent more than 20 years on one problem, longer than almost anyone alive. What happens if human beings build a machine genuinely smarter than humanity? Their answer is the hard edge of this series. If any group, anywhere on Earth, builds that machine using anything like today's methods, and anything like today's understanding, then everyone dies. They mean it plainly, not as a mood, not as a slogan. This is the most direct reading in their view of how modern AI is made, how little of it we can inspect, and how a stronger mind would move through a weaker world. The case is not that one reckless company might make a bad product. It is not that a chatbot will become rude, or that automation will move too quickly, or that a government will misuse a tool. Those are real questions. They are not this question. This question is loss of control, whether we can build a mind above us, point it where we mean to point it, and remain the ones steering. That is a heavy claim to place on the table. It is also not a claim you should swallow whole because the names are famous, or spit out whole because the conclusion sounds too large. Some of the case rests on ordinary facts about how these systems are trained. Other parts are strong extrapolations from those facts, and a few are still genuinely in dispute. The ground changes under your feet as the argument climbs, so we are going to climb it slowly, borrowing neither the author's certainty nor their critics' comfort, looking instead for where the steps hold, where they narrow, and where the real jump begins. Start with the objection that should be in your mouth. How could anyone know what a technology that does not exist yet will do? Prediction is difficult, especially about the future. Mostly yes. I cannot tell you next week's lottery numbers. One row of digits looks just as plausible as another. But I can tell you something about the same ticket with almost perfect confidence. If you buy it, you will lose. The exact numbers are unknowable. The outcome is not. Drop an ice cube into hot water. Ask for the path of one molecule and the room turns to fog. Too many collisions, too much motion, more detail than anyone could hold. But ask what happens to the cube, and the fog clears. It melts. Half of physics has this shape. We cannot follow the path. We can still call the destination. That is the difference the book wants you to feel in your bones. A hard call asks for the wrong kind of precision. An easy call finds the angle where the noise cancels out. Good forecasting is not seeing everything. It is noticing when one part of the future has gone simple. History keeps giving us this split. If something is allowed by the laws of nature, and useful enough, the destination is often visible long before the date. Heavier than air flight, atomic weapons, a human footprint on the moon. People saw those endpoints before the world knew how to reach them. The date was another matter. In 1901, Wilbur Wright was so worn down by failed gliders that he told his brother human flight might still be 50 years away. He was off by 48. 2 years later, at Kitty Hawk, the machine lifted. He had the destination right. He had the date wildly wrong. And he was the man building the answer with his own hands. Our own moment has the same cruelty. Image recognition broke open in 2012. A program beat the world's best Go player in 2016. Fluent public chat systems arrived in late 2022. Stronger reasoning systems followed in 2024. The dates surprised people whose job was to watch the dates. In 2015, many computer scientists would have put human-like chat 30 or 50 years away. It took about 7. That does not mean every next step will be fast. Sometimes a field stalls, sometimes the last mile is the longest mile. The lesson is narrower, dates are treacherous. Even experts miss them from inside the workshop. Destination and date are different questions. Mixing them up is how a forecast becomes a fog machine. Now place superintelligence inside that frame. When will a machine arrive that is smarter than humanity in the ways that matter? The honest answer is, no one knows. A year from a booster is theater. A year from a skeptic is usually theater with better lighting. But the book asks a different question. If such a machine does arrive, built through systems we train more than we understand, what happens then? The authors say, that is the ice cube. This is where serious people part company. Some think the outcome is still genuinely open. We might keep control. We might learn fast enough to stay ahead of it. Or we might build something stronger than us that is, somehow, still shaped by us. Every past technology arrived trailing dangers, and every one of them also arrived with room to adapt. The strongest version of that hope is not foolish. It says intelligence is useful, partly because it lets you understand what others want. A more capable system might be easier to train, easier to test, easier to ask for help. The world is full of feedback loops, regulations, audits, markets, rivals, and failures that teach before they kill. Perhaps superintelligence is not a cliff. Perhaps it is a long slope with warning signs. The book's reply is that this case is not like past technologies in the one respect that matters. A technology can be dangerous and still remain a tool. A mind stronger than its makers is not just a sharper tool, it is a player. And if the player wants something even slightly different from what we meant, the usual human move, notice the bug, patch the system, try again, maybe arriving after the decisive moment, that is the hinge. Not whether AI can cause harm. It already can. Not whether people in the field are worried. Many are. The hinge is whether a superhuman intelligence, built under present conditions, is the kind of thing we can still steer once it exists. Everything after this episode is background for that hinge. There is one quiet habit of mind that makes this argument harder to hear. Tomorrow usually looks like yesterday. The shop's open. The road is where it was. The sky does not change its chemistry while you sleep. Most days reward the assumption that the world will keep its shape, but the long story does not. The air in your lungs is the afterlife of a catastrophe. More than 2 billion years ago, small living things learned to feed on sunlight and gave off oxygen. To much of the life then on Earth, oxygen was poison. It gathered in the atmosphere. The old world ended. A few lineages learned to use the poison as fuel, and everything breathing now descends from the turn. Normality did not bend. It broke, and a new normality grew on top of it. Bare rock turned green. Fields turned into cities. Fire, writing, engines, radio, nuclear weapons. Again and again the floor moved. The people standing on it had reasons to expect continuity. They were not stupid, they were early. It will probably be fine can be a wise sentence when it is earned. Unearned, it is only a lullaby. The machine in question does not exist yet. That fact matters more than any comfort line I could give you. In the 1950s, clear-eyed people looked at nuclear weapons, then at human history, and expected nuclear war. It was a reasonable forecast. It has not happened. Not because the bombs were harmless, because enough people saw the destination early enough to spend decades turning away from it. That is the use of an easy call. You don't make it to win an argument, or to perform alarm. You make it to buy time while time can still be bought. Foresight is the human trick. We look ahead, imagine a branch, and move before the branch closes. Used well, it is why warnings matter. Used badly, it is just dread with a calendar. So this series is going to build the background piece by piece. How modern AI is grown, not crafted. Why training a system is not the same as choosing what it wants. Why a smarter mind might move through the world in ways we cannot follow. And where the book's case is strongest, and where it has to reach. The point is not to make the conclusion feel dramatic. The conclusion is dramatic enough. The work is to make each step quiet enough that you can inspect it. It begins with the thing we keep talking about handing over, the thing we keep calling intelligence. We use the word as though we already know what it means. We are about to find out whether we do.